Greeting everyone, I'm Ling. My FYP topic is Performance Analysis of Passively Q-switch Fiber Laser by using SWCNT-PVA Saturable Absorber, supervised by Dr. Azura Hamzah. Pigmentation disorders such as melasma, dark circles eye are caused by a usually harmless condition in which patches of skin become darker in color than the normal surrounding skin due to the excess of dark skin pigment that deposit in the skin. Tattoos, a permanent body modification that using ink, dye, and pigment to make a design into the dermis layer of the skin to change the skin pigment into their desires. People may find out regret for their tattoo and wish to have the removal of a tattoo. In order to fade or remove pigmentation which occur naturally or artificially, the most common way to be used is laser treatment. Nowadays, the commonly used laser is Q-switch fiber laser. Hence, I would like to introduce to you Q-switch fiber laser and how it is important. Laser, a device that emits amplified light by the stimulated emission of electromagnetic radiations. There are many different types of laser categorized by their operational wavelength, material used to generate the laser beam, and their applications. From the perspective of material, a laser with the solid-state grain medium will have better performance due to its efficiency and stability. Out of the solid-state laser, fiber laser is one of the most reliable laser type in the past decade due to its potential applications, which we commonly heard in communications, optical sensing, and nevertheless, as we mentioned before, it also can be used in some treatment and otherwise. A Q-switch fiber laser has been chosen to be widely used in medical treatment, especially for methodology treatment from various types of fiber laser. The concern of Q-switch fiber laser is being applied are based on two perspectives, which are the result and safety of the laser treatment. The factor affecting the Q-switch fiber laser, which are Q factor and regulation of intracavity loss, generating the short but energetic optical pulse, which are safe for human dermis layer and providing great result in fading and removing the pigment on their body parts. Q-switch fiber laser can be achieved by active or passive technique. In my research, I would like to emphasize the passively Q-switch fiber laser possesses the advantages of simple implementation and an economical approach for producing pulses with high power as it acquires great stability at a low cost and compact system. To analyze the performance of Q-switch fiber laser, which is also the main purpose of this research, a saturable absorber is being used. The reason we're using the saturable absorber to analyze these non-linear optical absorptions because they are comparatively low cost in manufacturing, which is more economical, and the wider operational wavelength which provide the better performance. A single-wall carbon nanotube, also known as SWCNT Saturable Absorber, is selected to be used in this research as it possesses several optical properties such as low saturable absorption, which minimize the power losses, and great nonlinear light absorption due to its ultra-wideband operational wavelength, which exactly fulfill the characteristic that essential for Q-switch fiber laser analysis. The objective of this study are to appraise the passively Q-switch fiber laser with and without saturable absorber for determining the significance of saturable absorber in performance analysis of Q-switch fiber laser and to analyze Q-switch fiber laser with its performance parameter of repetition rates, pulse energy, pulse width, and output power. Also, a comparison between different ratios of SWCNT saturable absorber will also be conducted through this study to investigate the best ratio of SWCNT saturable absorber with the best performance parameters. To accomplish the objective of this study, a circuit connection as shown had been set up. A laser diode which functions as a pump laser supplying the power is connected to a wavelength division multiplexer WDM multiplex the optical carrier signal into a Abraham doped fiber EDF of 1.7 meter and then transmit through a unidirectional isolator to prevent unwanted feedback into the saturable absorber between the fiber ferrule. The light signal is then propagated to the transmission line with and without a saturable absorber to figure out the importance of saturable absorber in such analysis by using an optical spectrum analyzer OSA. The connection of the circuit with the saturable absorber is then being used to analyze the Q factor parameters with the assistance of a power meter PM, which used to determine the output power, and a mixed domain oscilloscope MDO, which employed to demonstrate the pulse trend and the parameter of pulse width and its repetition rates. The pulse energy of the laser is then computed by a ratio of the output power to the repetition rate following the mechanical power equations. The experiment is repeated with three different ratios of SWCNT-PVA, which are 1:1, 2:3, and 3:2 for an investigation of the best ratio to achieve high pulse energy, output power, and repetition rate, but short pulse width within the range of pump power which provide a stable wavelength. Referring to the figure, the Q-switching wavelength of ratio 1:1, 3:2, and 2:3 are positioned in the conventional band, and the output spectra with saturable absorber is found shift forward. The presence of the saturable absorber brought a significant impact on the reduction in wavelength for the self-starting Q-switching to initialize. The output power is directly proportional within the pump power range required by this saturable absorber, indicating the pump characterization regardless of the ratio of SWCNT-PVA. By studying the Q-switching threshold, the ratio of 2:3 possesses the greatest threshold input. Meanwhile, it will also demonstrate a comparatively greater output power. When increasing the threshold power, the repetition rate of the ratio 3:2 is recorded as the highest, which is approximately double the other ratios of SWCNT saturable absorber. This is due to that more gain is supplied to saturate the saturable absorber, which means it possesses the best saturable absorption among the sample saturable absorber being analyzed. Concurrently, it could produce more pulse within the same durations. As the pulse interval is inversely proportional to the repetition rate, it decreases with the increase in pump power for each ratio gradually. SWCNT-PVA of ratio 3:2 has the lowest minimum pulse width as it emits the highest repetition rate, as encapsulated in this figure as 2.39 microsecond, which approximately half of the others. The pulse energy is directly proportional to the average output power and inversely proportional to the repetition rate. Hence, the ratio of 2:3 with the greatest output power and comparatively lower repetition rate produce the highest maximum pulse energy of 36.1213 kJ, which is generally 2.5 to 3 times higher than the others. In this figure, also we found that there is a slightly decrease in pulse energy is investigated for the SWCNT-PVA of ratio 1:1, which was occurred due to the thermal damage. Throughout the analysis of the experimental result, SWCNT-PVA saturable absorber of ratio 2:3 in a passively Q-switching is determined as the best ratio of saturable absorber because it performs the highest output power and maximum pulse energy, although its repetition rate and pulse width is not the most compact. In a conclusion, the objective of determining the significance of saturable absorber in the passively Q-switch fiber laser is achieved as the Q-switching EDFL system show forward-shifting output spectra, although with different ratio of SWCNT-PVA saturable absorber, prove that the presence of saturable absorber speed up the self-starting of the Q-switching. The purpose of parameter analysis and the investigation of the best SWCNT-PVA saturable absorber ratio for passively Q-switch fiber laser has been inspected, and the SWCNT-PVA of ratio 2:3 is the best as it achieves the highest maximum pulse energy and the highest output power with short pulse width. In future, the Q-switch fiber laser application is believed to widely employed not only in the laser treatment of dermatology, but also in other fields such as micromachining, telecommunication, optical fiber sensing, remote sensing, range finding, industrial processing, and extra. Hence, the performance of Q-switch fiber laser is thus very important in its future development in those fields. That's all from me. Thank you for listening.